Okay. All right. Very good. Well, we'll go ahead and get started then. First off, appreciate it. Thanks everyone for jumping on this webinar here. This is the first of a four-part series that we're going to be doing. We're covering biofilm pretty exclusively today. Our next topic is going to be covering algae in irrigation ponds. But I am really excited to have some feedback and hear what you guys want to learn more about. So appreciate everyone jumping on the call. My name's Justin Levitt. I work for Moliere, and today we're going to talk all about biofilm. So what's on the agenda today? First off, we're going to cover what the heck biofilm is. We're going to look at the biofilm life cycle, all the many ways biofilm can ruin your day, biofilm solutions, considerations, and then we're going to just recap the material and then do a few highlights on the next educational series that we're going to be doing here. There's a lot of information to cover. It's really just a few topics, but we're going to dive really deep. And so we'll probably have about 20 minutes, maybe a few minutes after for questions. So if you guys have questions, please just go ahead and write them in. And then at the end, we'll try and tackle those. Even if we don't get to your question live on the presentation at the end of this, we'll be sure to follow up. So don't hesitate, send your questions, and we'll do what we can to answer them. Okay, so what is biofilm? Well, biofilm is a complex and resilient structure formed by colonies of microorganisms, such as bacteria and fungi. So when we think about biofilm, it's important not to think about one singular bacteria or maybe one singular fungal. This is something that is a community of microorganisms. Now, these microorganisms adhere to the surfaces. They produce this slimy protective matrix. It's composed of polysaccharides, proteins, lipids, and other molecules. The short version to call this bioslime or EPS. It's technically a extracellular polymetric substance. This matrix helps microorganisms stick together, helps these microorganism communities stick to a surface, creates a very stable environment for their growth and survival. So that EPS that's being produced by the biofilm is a key part on why it is so difficult to manage biofilm. Key takeaway here, though, is that when we're talking about biofilm, it's a microorganisms community and that they are working together to produce EPS, which helps stabilize their environment. Understanding biofilm life cycle is really important. There's different strategies on managing biofilm, and how we go about these strategies really is important so that we can look at what are we affecting. Are we affecting the early stages? Are we affecting all stages, the final stages? And so understanding what this life cycle is can help you strategize how you want to implement your preventative and curative programs. So first on biofilm, there's that free swimming microorganism. This is technically before it's in its biofilm stage. This is not technically biofilm at this point, but there's that free swimming microorganism stage where they are moving through irrigation water, looking for surfaces that they can colonize. That next stage, the attachment stage, that's where they're producing the EPS or the bioslime. Typically in the presence of organic material, nutrients, and water. This really helps them adhere to the pipes firmly. And then as they develop, there's this growth stage. This is when we start to get into some real trouble. This is when the biofilm grows and matures. There's more microorganisms joining. They produce even thicker amounts of this EPS or that bioslime, becoming a really complex structured community. From that stage, it becomes very difficult to manage. The EPS, that bioslime that they produce, is largely protecting these microorganisms underneath, and it's very difficult to manage biofilm aggressively when you're in this growth stage. Now, just like most things in biology, whether we're talking about spider mites or aphids, there's that dispersion stage, right? So the biofilm's so happy, it's grown to such a point where it's actually starting to break off and spread and disperse and colonize new areas of the irrigation system. And so this causes that biofilm spreading. And this kind of highlights one of the key problems with biofilm is you can't just manage it a little bit. You really have to manage it from the tank all the way down to that last stripper, because that dispersal stage, if you have hot spots of biofilm in a single area, it can very easily start to spread into other areas. And what we end up finding ourselves doing is playing a little bit of cat and mouse if we're just chasing hot spots and not looking at a sort of complex, holistic, preventative, and curative program. There's a lot of hidden costs to biofilm. One cost that's not so hidden is clogged emitters. As a grower, dealing with clogged emitters is the worst. It is probably a stage at which if you see clogged emitters, that's probably some of the worst of the biofilm. Those clogged emitters are going to be causing you to have crop loss. If you can catch it early enough, maybe you won't have crop loss, but you can very easily lose that yield potential. The more hidden costs of biofilm, though, are that reduced water flow in uneven irrigation. In uneven irrigation is kind of like having a million little paper cuts. It costs you along the way. And so what I typically see is we start to categorize, do we have a real biofilm problem based on if we have clogged emitters or not. But what I would challenge you, though, is that there's a lot of hidden costs before you even get to clogged emitters, and that biggest cost is really uneven irrigation. When you think about how we're delivering nutrients, insecticides, fungicides, PGRs, how we're delivering those to the plants is typically through the water. And so we work really hard as growers and operators to come up with the best plans, right? Our nutrient programs are on point, our preventative programs are on point. All we need to do is deliver these active ingredients to the plant so it can grow properly. But what typically happens through biofilm is uneven irrigation. So if you're planning on delivering your fertilizer program, but 30% of your crop is dealing with biofilm, instead of delivering that water at maybe 1 gallon per minute, you might be delivering that irrigation water at half a gallon per minute. And so what that means for 30% of your crop is that it is losing 50% of the resources that you plan to give it in that day. And so it's not all that uncommon when you start to solve your biofilm problems that you have an increase in total yield. And that doesn't necessarily come from the best looking plant growing better, but what that comes with is a total increase in yield by consistently and evenly delivering the water and all the inputs that you mean to give the crop. Because that can be a real concern. If, for example, you're giving a insecticidal drench for aphids and your active ingredient needs a specific amount of application for it to be effective, if you have biofilm that is clogging and causing uneven irrigation, it could be very much the case that insecticide or fungicide is not delivered at the active ingredients amount that it needs to be effective. And that, in a lot of cases, where we can have hot spots come from. So if you are noticing different hot spots around the greenhouse, one thing I would recommend you look at is how are those drippers operating? Are you actually delivering 100% of that fertigation or of that fungicide or insecticide, or are you being robbed by this biofilm? So biofilm can cause quite a bit of issues with that uneven irrigation even before it's clogging emitters completely. But it can also rob your fertilizer, right? So these biofilms will consume fertilizer, and that really helps them grow very actively. They can consume oxidizers. They can change the pH of your water as well. So when we think about biofilm, it's really easy to say I have it or I don't have it, or biofilm doesn't cause that many issues, but we end up correcting biofilm downstream in a lot of ways. And one of the main concerns that I see with biofilm is that increase of pathogens in your irrigation water. It's really interesting, right? Biofilm is a complex community of microorganisms, and that can include things like fusarium, pythium, and phytophthora that are growing in your lines as water is passing and delivering that to the plant. So it's not that uncommon where I will see an incredibly clean tank of water, and we can test those for pathogens, and generally they come up pretty clean. But if you go, and I would recommend you go and do some pathogen testing at your tank, but do pathogen testing at that very last dripper at the end of the greenhouse or at the end of the operation and see what sort of story that tells you. Because what's going on from that tank of water to that last emitter is really important to understand, where our challenges are. Biofilm sometimes feels like it just won't go away. If you guys have ever done or worked a lot in propagation, biofilm reminds me a lot of fungus gnats and how you have to deal with them. Fungus gnats are a constant pressure on propagation, and the reason for that is because growing crops and propagation share the same favorable conditions as growing your fungus gnats, and that is the exact same really for biofilm. Biofilm loves nutrient available water, constant or even frequent water flow. When you're not irrigating, if you have stagnant water, these are all favorable conditions for biofilm, and of course organic matter. There's a lot of organic matter in horticulture facilities. So it requires constant prevention in a lot of cases because the conditions are also constantly favorable for growing biofilm. There are peaks, right? There are times when it's easier or harder to manage biofilm. What I would recommend to successfully start off the season clean. So if you have an empty greenhouse, you can use oxidizers very effectively. When we think about how to use a oxidizer effectively, it typically comes down to contact strength and also contact time. So if you have an empty greenhouse and you can use your oxidative products to soak and flush out lines a couple times before the season starts, then you can start with some really clean lines, and I strongly recommend that. But what's really difficult is dealing with these biofilms during the growing season, because during the growing season, typically you don't have the availability to shock your lines. You typically don't have the time or availability to use these high rate oxidizers. And so you end up trying to do this balance. And if I'm talking to a bunch of growers here, you guys understand what I'm talking about when I say it's easy to use low rates of oxidizers and it's really risky to use high rates of oxidizers. I've been in that position before where you want to use an oxidizer, but you also see that there's $500,000 or $100,000 worth of crops on the ground, and you don't want to be the person that sent too much chlorine or too much hydrogen peroxide or ozone or other oxidative product. And so it can be risky to utilize high amounts of oxidizers, and that is typically what is required if you're going to try and manage the biofilm and penetrate that EPS matrix. Remember, that matrix is what is preventing the effective use of that oxidation. Underneath that EPS matrix is the microorganisms that we need to be targeting. It takes high strength oxidizers to do that, and that causes a lot of risks for our crop. And really not to mention that it's quite difficult to carry the required part per million residual from your source water or your injection point all the way down to the last dripper. If you are doing this successfully, typically what that looks like is a highly consumable cost year over year or month over month to keep these lines clean. But again, that EPS matrix, it's incredibly effective at reducing the oxidation efficiency, especially when we're in those later stages like the growth and dispersal stages where that EPS matrix is very well developed. In some cases, the biofilm can even become resistant to these oxidizing ingredients. So what I would recommend, of course, is trying to start clean. So if you have an empty greenhouse and you can soak your lines, I do recommend doing that. But during that in season, Oxidation as a single source mode of action may not be enough to maintain clean lines. I want to talk about how nanobubbles can provide a different mode of action. But before that, we need to really understand what nanobubbles are. So nanobubbles are exactly what they sound like. It's a bubble of a nanoparticle size, 200 nanometers or smaller. And you can consider understanding how this size works. They are 25,000 times, or sorry, 2,500 times smaller than a grain of salt. So they are incredibly tiny. Now, these nanobubbles are stable and long lasting, and because of their size, they're neutrally buoyant. So they're not rising out of solution like you would see larger bubbles. So they act like a charged particle. They're stable, long lasting, and hydrophobic. So they're repelling from water, sticking to hydrophobic surfaces like irrigation piping. And they're also incredibly effective at enhancing that gas transfer, right? Whether we were wanting to dissolve a lot of oxygen into water, dissolve a lot of ozone into water, nanobubbles enhance that gas transfer. Today, we're going to try and really stay on topic and talk about biofilm and not so much about dissolved oxygen and other aspects of nanobubbles, but understand there's a lot of unique characteristics that help utilize successful watering. When we look at biofilm, I like to start at the very end and then work backwards. So when we think about that last dripper or that last emitter, how are we going to maintain clean lines? And so what's really unique about nanobubbles is that mode of action is different. Typically, our mode of action that we're trying to manage biofilm is always oxidation. Let's inject oxidation. Let's provide oxidation, and that is incredibly helpful. But when we combine nanobubbles and that oxidation, we see significantly better results. And the reason for that is because that nanobubble is providing a different mode of action. They're actually removing these contaminants. Keep in mind, right? There's trillions of nanobubbles in your tank. There's trillions of nanobubbles running down your lines when you're running irrigation. And these nanobubbles are dislodging and sweeping away, particles in the process. And so that EPS matrix is really difficult to manage just on with oxidation. But what nanobubbles do is they interface with that EPS matrix and they start to chip away at it, start to create channels and increase that efficiency so that oxidizers can actually start to work on the microorganisms below that biofilm slime or that EPS matrix. So the main mode of action in which we see nanobubbles working is through a physical scouring and actual removal. And then the second mode of action is if you guys remember being attracted to hydrophobic surfaces. So as you start to clean your lines through that physical scouring, you'll find that nanobubbles actually start to adhere to the piping line and make it very difficult for these biofilms to reattach. So if we go back to the biofilm life cycle, we have that early free swimming microorganisms. We have that pre-attachment or early attachment where oxidizers can be effective during those stages. Then we have those growth and dispersal stages. It's very difficult to have effective oxidation during those stages due to that EPS matrix. But again, the nanobubbles help manage those later stages by removing that EPS matrix, but also preventing the reattachment of the dispersal of biofilm. This was an in-house test utilizing air nanobubbles. This wasn't involving any sort of oxidation. And so what we saw in standing water, there was a 20% increase in efficacy of particle removal. And then in moving water, we saw a 30% increase in efficacy of particle removal during the moving water. So just nanobubbles on their own are increasing that particle removal. So anytime you're running your irrigation, which probably about this time of year is almost always, you're getting that increased particle removal and lining your piping with nanobubbles that help prevent that reattachment from particles. So as I mentioned, we want to start at the end and work backwards. So working backwards means, taking a look at the source water. Treating water at the source is definitely not the only answer, but it is a great place to start. So these microorganisms are going to, eventually turn into biofilm and provide trouble, downline. What can we do to sort of narrow that funnel and reduce the amount of microorganisms that are going to cause us problems downline? And so setting some target oxidation or ORP goals are going to be key for helping ensure that your biofilm pressure is considerably lower. So when you think about ORP or oxidation reduction potential, that could be its own webinar on its own, but you can go too low, where you have really high risks of biofilm, really high risks of pathogens, things like Pythium and Phytophthora, but also you can go too high on your ORP. So ORP above 450 or at 450 and above, you start to precipitate out things like iron. That can be worth it to adjust your fertilizer program for that. But also as you start to creep up into higher and higher ORPs, you can start to cause oxidative stress or even accumulate different oxidizer residuals that can be harmful. So personally, I like that between 3 to 450 zone. If you have questions about ORP, feel free to reach out to us. There's a lot of different ways you can increase ORP in your source water. You can utilize things like ozone. You can utilize things like oxygen or chlorine or hydrogen peroxide. There's a lot of different ways that you can increase that ORP. One other thing I'll mention that is really important is that pre-filtration. The better you're filtering the water, the less carbon you have in your water, the less biology really you have in your water. That's a better starting point. So if you can have excellent filtration, maintain a higher ORP between that 3 to 450 millivolts, you're going to be setting yourself up for success to have lower pressure biofilm, downstream. There's a couple different options when you look at trying to add nanobubbles into your preventative program. A lot of growers I work with already have a oxidative loop in place, right? They're injecting something like a hydrogen peroxide, like they're using something like a Sanidate or a Xeritol, or maybe they're injecting a hypochlorous acid, or they're injecting maybe even ozone. So with these oxidizers, as we know, one mode of action may not really be enough to manage biofilm and may not be effective enough to manage your pathogens. But if you want that increased oxygen and increased nanobubbles as a partner to your pre-existing oxidative program, this base Neo here on the right is going to be able to provide you that oxygen and nanobubbles. Now, on the other side, if you want to just reduce your consumables, right, you want to reduce the amount of chemicals you're purchasing that you're using as oxidizers, or maybe you don't have anything in place yet and you want to add, oxidation and nanobubbles, then we do have a Moliere ozone nanobubble generator, where we are injecting ozone and injecting through the dissolved and nanobubble form, which creates some very unique results. One thing that we notice, don't just take our word for it, but when we take nanobubbles and utilize them with ozone and even other oxidizers, that efficacy is drastically increased. So here in the first study that we're looking at grams of ozone per kilowatt, you can see that the Moliere injection method is over 50% more efficient. What that energy efficient, what that essentially means is that you can have a higher impact, a stronger impact with a smaller piece of equipment, typically lower cost, lower maintenance. But also, if we move over to that next study, a very big difference in improved surface cleaning. Dissolved ozone on its own is a strong oxidizer, but what we know and have learned about nanobubbles is that they are very effective at removing particles, which is the main mode of action in which that they're providing for biofilm removal. So that removed particle with that interaction or interface of ozone drastically it increases that cleaning efficacy. Of course, faster disinfection rates, extended dissolved ozone residual, which essentially just means more contact strength and contact time with your problems. One more slide that we're going to look at. This is from the University of Maine, where they took nanobubble ozone solutions and compared them against the conventional ozone, and then as well as tap water. They used acrylics and PVC as their material, and as you can see, the PVC on ozone nanobubbles was about 1.5 times better. Of course, about 2 times better than actual tap water. So these nanobubbles are providing a very big difference. And what we understand about complex problems is there's typically never one single mode of action that's just going to take care of everything. It takes multiple modes of action, and that's what's provided when you combine nanobubbles with oxidizers, whether that's ozone or chlorine or hydrogen peroxide. So to quickly recap, because I'm a little bit over on time already, biofilm is a complex structure of microorganisms that produce EPS. That EPS is what makes them so difficult to manage. One, because it can continuously spread throughout your system, but also it protects them from the typical mode of action that we are utilizing, which is oxidation. Pre-biofilm formation starts as free-swimming microorganisms. This is why we want to have really good filtration. This is why we want to have a higher ORP in our irrigation stored water. This later transitions into the attachment and dispersal stages. Of course, it's really important to have that downstream treatment as well. As I mentioned, nanobubbles plus oxidation equals best results. You could even just say multiple modes of action tackling the same problem is also going to give you the best results. All right, well, I appreciate everyone's time here. This is one of 4 educational series we're going to be holding. We're going to try and keep them short. I'll try and stay on time next go around. We're going to cover algae management in irrigation ponds. If you guys want a recording, I think we're going to send one, but if you have questions, feel free to reach out to me at justin@moliere.com. And I'm really interested in what do you want to hear more about? Oh, here's my favorite slide. What did the owl say at the end of the presentation? Who's got questions? Thank you.